In Module 4, Lesson 7, we're going to replace the letters with numbers. So we start off with this square. And they ask us, what is the length of one side of this square? Well, one side of the square is 3 units long. The formula for the area of a square is side times side. Or, since this is repeated multiplication, we could write this as side squared. So this square's area as a multiplication expression would be 3 times 3. And our final answer then is 9. And these are square units, because we're measuring all of this space inside, and we can see that there are 9 square units. You might even consider them tiles that make up all the area inside the square. Now we could count the units on this square that's up above, but in most squares we're not going to have all of the units marked out for us. So we look at this square. Its side length is 23 centimeters. That's too many tiny units to draw. So the expression that we should build to find this square's area would be 23 to the second power. We're multiplying 23 times 23 because that's how we find the area of a square. The area of this square, 23 to the second power, which is 23 times 23, is 529. And they've told us the units, which are centimeters, and those centimeters are squared because remember, what we were looking at in the square up above were little squares that make up the whole space inside. So it's not 529 squared, it's 529 little square centimeters that would fill this space. Looking at exercise 1, they're asking us to complete the table for both squares, and keep in mind that the drawings are not to scale, meaning that you can't measure them to find the information. So the length of one side of the square in our first square is 4. The square's area written as an expression would be 4 to the second power, or 4 squared, and written as a number would be 16. And those are square units, which we simply write as units squared. The second square, each side is 25, and as an expression, it would be 25 squared. And written as a number would be 625 inches squared, or square inches. Looking at example 2, we can see on opposite sides of this rectangle that one side is labeled B centimeters and the other side is labeled 8 centimeters. So B equals 8 because we know in a rectangle that opposite sides have the same measurement. Then they ask us, given that the second rectangle is divided into 4 equal parts, what number does the X represent? So we notice that underneath they're showing us that each equal part is 4 centimeters, and X up above the rectangle is representing 2 equal parts. So the number that X represents is 2 times 4, or 8 centimeters. The total length of the second rectangle must then be 4 times 4. There are 4 parts, and each part is 4 centimeters. So the length of that rectangle is 16 centimeters. If the two large rectangles have equal lengths and widths, they're asking us to find the area of each rectangle. So then we have information in the top rectangle about the width and information in the bottom rectangle about the length. The top rectangle we know was 8 centimeters. And again, when we find area, we're multiplying length times width. And the bottom rectangle we found was 16 centimeters long. So their area then would be 8 times 16, which is 128. And again, our units are square centimeters. Now let's practice. They're asking us to complete the table below for both rectangles, and keep in mind that these drawings are also not to scale. Using a calculator would be appropriate for these numbers. So our first rectangle, which is already boxed out for us, 1, 2, 3, 4, 5, 6, 7, is 7 units long, and its width, 1, 2, 3, 4, is 4 units. So the area written as an expression would be 7 times 4, and as a number would be 28. And again, these are units squared. Our second rectangle has a length of 46 meters. The width is 32 meters. And written as an expression, we would do 46 times 32, which then is 1,472, and these are meters squared, or square meters. Example 3. L represents length. W represents width right here. So W equals width. Length, width, and the H equals height. Since we know the formula to find volume is length times width times height, what number can we substitute for the L in the formula? And remember that these are equal. So L will be 6. We know because it matches the same location in both rectangular prisms. Next, they ask us a strange question. What other number can we substitute for the L? Well, no other number can substitute because only one can substitute for one variable. Then they ask what number can we substitute for the W, and W can be substituted by 2 because it matches the same location in each prism. And then our H, and we've kind of scrolled the picture off here, so let's go back and look at it. We can substitute 8 for H in the formula, and then to determine the volume of the second right rectangular prism, we're going to multiply 6 times 2 times 8. 6 times 2 is 12, and 12 times 8 is 96. Those units were centimeters, and so it is centimeters, but these are cubic centimeters. And by cubic, what we mean is that they're little cubes that are 1 centimeter each way, kind of like mini ice cubes. Because in order to fill the space in terms of volume, you must have cubes, not just little square tiles that just lay flat. This is a 3D object, and so our units are in cubed, or the exponent of 3. We'll practice. They've given us a table for both figures. So in the same way that we worked on the others, we'll take a look at our first rectangular prism. The length will be 12, our width will be 5, and our height will be 15. And writing the volume as an expression, we would do 12 times 5 times 15. And then written as a number, that will be 900 cubic units. And our second rectangular prism, we have 23 for our length, 4 for our width, and 7 for our height. Our expression then is 23 times 4 times 7, which is 644. And our units now are centimeters cubed, or cubic centimeters. Please remember that an expression is a numerical expression if all of the items in the expression are numbers. It's an algebraic expression if you add any variables. You certainly can replace some of the variables with numbers if you have the information to do that.